day to all the Form 4 and Form 5 students. How are you? Okay, so we have actually reached the end of this topic. So today I will just discuss one question, which is question number 12. If you follow my lesson, every video you follow, then I think you master the measure of dispersion well. Because I think the syllabus for Form 4 is a very good revision for Form 5 student for your additional maths. So the question here are quite challenging and quite interesting, and is more like Kebat's question, HOTS. Okay, so please try to go through the video when you're free. Okay, so for this topic, we actually cover many things, and I think this question number 12 is the most difficult. Okay, you need to understand some basic concept, so please go through the notes that I will discuss later before we attempt question number 12. Alright, so before we answer question 12, we need to understand the concept behind the most suitable measure of central tendency. So the role of measure central tendency is to determine the central value of a set of data. So there are three types of measurement commonly used for measure of central tendency. They are mean, median, and mode. So mean is the measure of central tendency that involves all data collected. Okay. Hence, it is said to represent the whole set of data. Okay. However, when there is an extreme value in the set of data, mean cannot give us an accurate picture of the data, as mean is influenced by the extreme values. So for example here, okay, this is ungrouped data. We have 45, 58, 60, and 97. So we have the one data which is 97. So we find the mean 61, mode is 45, and median is 58. So from the data above, mean is not suitable to represent the measure of central tendency because of existence of an extreme value 97. Therefore, the more suitable measure is median, because median is not influenced by the extreme value. So mode is a good measure to be used in business matters. Okay, for example, the manager of a school canteen want to know which food is most in demand by students. He would need to know the mode, and sufficient orders can be made proactively for the business from the suppliers. Thus, the mean and median are not suitable in this case. Okay. Okay, normally for the distribution that is largely skewed to the right, and this indicates that the data has extreme values. In this case, median is more appropriate measure of central tendency rather than mean or mode. So briefly, to determine the most suitable measure of central tendency for group data can be summarized as follows. Case 1, skew to the right. Case 2, skew to the left. And case 3 is symmetrical distribution. So for distribution which are largely skewed whether to the right or to the left, as shown in a histogram 1 and 2, median is the most suitable measure of central tendency. For symmetrical distribution or almost symmetrical distribution, as shown in histogram number 3, mean is the most suitable measure of the central tendency. Alright. Okay, let's discuss the effect on the range, interquartile range, variance, and standard deviation. Let's say we have the data 1, 2, 3, 4, 5, 6, and 14. So the range is 14 minus 1. Okay. The interquartile range is 6 minus 2, 4. mean is 35/7/5, and the variance is the 16, and standard deviation is 4. So from the list of numbers given, you notice that all the values are between 0 to 7, okay, except for one value, which is 14, 1, 4. So the 14 is known as extreme value. Due to this extreme value of 14, so the range is 13. But without the extreme value, the range is 6 minus 1, which is 5. Okay, so therefore, if there is an odd observation in the set of data, the range will provide a wrong picture of the data. So for the interquartile range, the existence of the extreme value does not affect anything. Interquartile range, it does not affect anything because the extreme value of 14 is not taken into consideration. Okay, so in general, the interquartile range is more meaningful. Interquartile range is more meaningful as compared to the range. Okay, I have explained with the example just now. So interquartile range is more meaningful compared to the range because it avoids giving a wrong picture when there is an extreme value, okay, in the set of data. So from the calculation, the extreme value yields a big value of variance, that is 16. It causes the variance become very big. So it shows that the spread of a set of data is very wide. So then the variance is also large. Okay, so this shows that the data is not consistent. So the same goes to the standard deviation. If without the extreme value of 14, the standard deviation is just 1.71. Okay, but because of the extreme value 14, now the standard deviation become 4, which is very big. Okay, so this will show not the actual situation, not the actual picture, okay, of the set of data. Let's see the question number 12. The table below shows the time taken in hours by 32 pupils to do revision in a week. Okay, you are given a table with time in hours and number of pupils. So for question number A, calculate the range, interquartile range, variance, and standard deviation of the distribution. Okay, I think this part all the student can do. Range, interquartile range, variance, and standard deviation. Okay, but please bear in mind this is in table form. Alright, for question B, state the most appropriate measure of dispersion to show the time spent on revision by the pupils. I think this question many of the students will say, I don't know how to do. Okay, so you have to state the most appropriate measure of dispersion, and then you have to justify your answer. Okay, justify your answer, give the explanation why you will choose variance, maybe you choose median, maybe you choose interquartile range, maybe you choose range, or maybe you choose standard deviation. Okay, so try first before we discuss further. Okay, let's discuss question number 12. The table below shows the time taken in hour for 32 pupils. Okay, so we want to find the range. So we take the highest 10 minus the lowest 1. So the range is 10 minus 1 is equivalent to 9. And then we want to find the interquartile range. Still remember Q3 minus Q1. So we will take 3/4 of the total sample. So we need to find the cumulative frequency. So we add one more column, okay, for the cumulative frequency, because we need the n. Okay, so the formula for interquartile range is 3/4n minus 1/4n. So we need to find the n. So start with cumulative frequency. One more row. 2 start first. 2 plus 5 7, 7 plus 6 13, 13 plus 9 22, 22 plus 6, 28, 28 plus 2, 30, 30 plus 1, 31, 31 plus 1, 32. Okay, so n is 32. So 3 over 4 times 32 minus 1 over 4 times 32. So the 24th value minus the 8th value. So the answer is, the 24 is lies between 28. So on top of 28, you look for 5. Okay. On top of the 13, because the 8 is lie on 13. On top of 13, you find the number on top of 13 is, the time is 3. So 5 minus 3. So the interquartile range is 5 minus 3, which is equal to 2. So for this one, for mean, it involves frequency. So we choose a formula with frequency. Okay, so we will take frequency times the score. Total frequency 32 over n. N is 32. So it's 125 over 32. So the variance is sum of the fx squared over n minus mean square. So that means we need to take the frequency times the data. Okay, frequency is given by number of pupils, so it's 2 lah. So we will copy the frequency and then the data we square. So 2 times 1 square, frequency not square, plus 5 times 2 square, plus 6 times 3 square, plus 9 times 4 square, plus 6 times 5 square, plus 2 times 6 square, plus 1 times 7 square, plus 1 times 10 square. So the answer is 3.210. So variance is 3.210. So standard deviation is square root of 3.210, which is equivalent to 1.792. Remember, answer must be in 4 significant figure. Alright. So the answer for part A is settled. We have solved all the equation for part A. Okay, so now we will discuss part B. State the most appropriate measure of dispersion to show the time spent on revision by pupils. So if you draw the dot plot, still remember, we list out all the number with the frequency. So that means we have 1 repeated twice, 2 repeated 5 times, 3 repeated 6 times, 4 9 times, and 5 got 6 times, and 6 got 2, and 7 1, and 10 1. So if you list out, okay, all the number and then you sketch a dot plot, okay, so it seems like there is an extreme value, okay, but we didn't go in detail and do calculation, but we just assume that 10 is an extreme value. So as I say just now, okay, the interquartile range is more meaningful as compared to the range, because it avoids giving a wrong picture when there is an extreme value in the set of data. Okay, so in general, the interquartile range is more meaningful. So we'll choose interquartile. Okay, because the range will give us a wrong picture of the data. Okay, the range will provide a wrong picture of the data, so we prefer to choose interquartile range. I think we are not going to find out whether the 10 is the extreme value, but it looks like the 10 is very far from the other data. So we will assume that there is an extreme value exists. So in this case, we will use interquartile range. Okay, as it is more meaningful as compared to the range. Okay, so that it won't giving a wrong picture when there is an extreme value exists in the set of data. Okay, so our conclusion is we will choose the interquartile range. Okay, we'll choose the interquartile range as the most appropriate measure of dispersion for the answer B. That means we follow the textbook. Alright, so we were just assuming that there is an extreme value or outlier exists. Okay? Okay, some of you might doubt that whether 10 is the outlier or not. So you wonder whether 10 is the extreme value or not. So in this case, because the dot plot is skewed to the left, so and the 10 is too far from the data, so we just do our assumption that 10 is the extreme value. So as I say, in general, interquartile range is more meaningful and is the most appropriate measure of dispersion when there is an extreme value exists. Alright, that's all for today. Okay, have a nice day.